Hey, Jonathan, how are you doing? Let's see. This is the beginning of algebra for you, and I wanted to give you a sense of how to begin, which we did in our first lesson, and also kind of where this thing is going. So I want to make a few videos that give you the very beginnings in a way that I think you can build off of. Okay. So let's see. We are going to start. Let's choose a nice color. How about purple? Okay. So first of all, I'm going to go into like do one or two videos that's just going to hit everything from the I've never heard of algebra before level so that you can absolutely know this stuff. Okay, so first of all, let's talk about arithmetic and algebra, two words that you've probably heard. And G-E-B-R-A. Okay. And what is the difference between these two things? Basically, there's only one key difference between arithmetic and algebra, but it's a really essential difference. Arithmetic is all about numbers and operations. 74 minus 12, all divided by 6 times 5, for example. And then you will crunch these numbers using the rules of PEMDAS, which I'm not going to go into heavily because that is a real arithmetic concept that gets pushed into algebra. But arithmetic is all about numbers to make it like super, super simple and operations. T-I-O-N-S, operations. Okay, great. That's arithmetic. And it's what most students are doing most of the time in a math class up until they start algebra, which is, often in the sixth grade, seventh grade where you are. And there'll be like little pieces of hints about algebra coming up. What is algebra? Algebra only includes one new thing, essentially, and that is the variable. Like, for example, X or Y or A or B or C or K or Q, letters that get used to stand for numbers. And that's the key difference between arithmetic and algebra. And a way that this sort of plays out, a really important way that this plays out, that I think is the best transition from arithmetic to algebra. And so we just kind of jumped in last time is when you're like a really young student, you're going to get like problems like 4 plus 3 equals something, right? And then you're a good student. So you write in 7 and you get a big check mark. Let's say it's in green that says you got the right answer. Okay. And then you move on from there and you might get 5 plus blank equals 11 as the problem. And then you write in 6. And again, you get a nice check mark because that's the right answer. And these are both considered sort of arithmetic problems. But what's interesting is the second problem really is an arithmetic in a sense. You can do it using just the understanding of arithmetic, but the only real difference between this and algebra is just using this little symbol here rather than just going whole hog and saying, what we really meant to ask was 5 plus some number x equals 11. X is the variable. And then to be really formal about it in algebra, what we're going to do is we're going to say, I want to solve this equation for X. And that means get down to a place where I can say X equals 6. And that is my answer. My answer is expressed as a little equation where X equals something. And that's how we express. So there's no longer a box that you fill in. There's a little form that we use. Okay. And then the other thing I wanted to cover in this video, and again, it's stuff that we covered, is we can now use this idea of X or a variable, but X gets used a lot. We'll switch out variables. It's fine. We did addition, 5 plus X equals 11. We could do multiplication. X minus 1 equals 7. And so the answer here is, let me put my answers in a different color. The answer here is x equals 8, because 8 minus 1 equals 7. So we found the answer that x equals 8. Okay. And then switch back to purple. If we have, for example, the variable b times 3 equals 4. So we have this variable b. Oh, wait, hold on. That's not right at all. We can do that, but I'm not going to do that. I was thinking of a number, and I tipped my hand. Let's just change this up to 15. Okay. So b times 3 equals 15. What is b? Something times 3 equals 15. B is 5, because 5 times 3 equals 15. So b equals 5, because 5 times 3 is 15. Okay. And then finally, let's do this in a totally different color, just because I'm getting sick of these. Q divided by 2 equals 7. Q divided by 2 equals 7. And that means, thinking about it, Q equals 14. 14 divided by 2 equals 7. Q equals 14. Okay, and that's the answer. So we can apply variables and create equations that use addition, subtraction, multiplication, and division. But an important thing, and this is probably the last thing I'll cover in this video right here, is that in algebra, we really try not to use these two symbols, the multiplication symbol and the division symbol. We're very happy with, let me put these in a different color. We're perfectly happy with the plus and the minus. We really like those. But we're not at all happy with the, and why is that? Well, for one reason, this time sign tends to get confusing with the letter X, and X gets used a lot. For whatever reason, X just gets to be the lead variable in all sorts of problems. So we try to move away from that X. Now, I remember in our class you said we might think about changing like b times 3 and expressing it as b dot 3. So you're aware of the dot symbol for multiplication, M-U-L-T, multiplication. But really, really, really in algebra, so much more, we tend to say 3b to mean 3 times b, or b times 3. We put the number up here, and I'll give you some terminology for that in an upcoming video. So the reason for that, I can get into a couple of reasons for that in the next video, but for now, let's just consider that that means 3 times b. So for example, if we have 4k equals 20, that really means 4 times k equals 20. And so that means k equals 5. Step back from that, and yes, 4 times 5 equals 20. That's right. Okay. And then the last little bit of information I'll give you in this video, and try to keep this short, is we really, really, really don't like this symbol at all. We try to avoid this symbol. You will see viral videos on YouTube where someone has given an expression using a time sign and a division sign, and then you have 100,000 or a million people all saying that it means two different things. Like, for example, 3 times 6 divided by 2. And just this symbol, these symbols here, can be thought of as ambiguous. And they're not, but they're confusing. They're not objectively ambiguous, like it's good math, but it's bad communication. Does that make sense? So we try to avoid this. I don't want to go into too much detail about that. I can rant and rave about YouTube videos in another setting. But when we say x divided by 6 equals 3, the better way to say this is x over 6 equals 3. These two things mean the same thing, but we use the fraction bar. And we want to step back from this and think, well, what number divided by 6 equals 3? That would be 18 divided by 6 equals 3. Yes, that works. And also, if you were to think of this as 18 over 6, a fraction, an improper fraction that you could rewrite as 3. So in this video, I've tried to give you a little bit of beginning terminology and understanding what the variable is, and also a little bit about why we don't want to use and why we want to break the habit of using the X for multiplication and save it for a variable, and why we want to get away from the division sign, which can be confusing if not objectively ambiguous. So, okay. So I'll save the next lesson stuff for the next lesson. I'll see you later. Okay.